Hello, my name is Jacqueline Dean, and this is my 2212 Lab 2, which is Charge Tape Revisited. The purpose of this lab is to create a model that compares two charged tapes, treated as point charge models, that have an electric force exerted on one another. We want to use basic physics principles in the model that we create to determine accurate charges and forces on the tape. This slide is almost identical to Lab 1. We're going to be using Newton's second law, which is force equals mass times acceleration. We're going to be using Coulomb's law, which is written right there, and you can see what every single variable is supposed to be. We're also adding superposition, which is the net electric force is equal to the first electric force plus the second electric force. I had a hard time putting arrows above, but you can use your imagination and pretend that there's vector arrows above those. For the model of this lab, we want to go ahead and assume some things. We're going to assume that air resistance is negligible. We want to assume that the charges are evenly distributed among the tape. We want to assume that each piece of tape has the exact same charge. We also want to assume that superposition of tape segments are all equal pieces and charges. Obviously this isn't true, but we're running this lab in a perfect world. This lab is a recreation of Lab 1. We use the same procedures as Lab 1, however this time, since we're using superposition, we're hoping for a much more accurate result. We're going to be breaking down the piece of tape into charges and different segments of charges and then adding them all together using superposition. So these are the starting conditions. They're almost identical to Lab 1. I'm not going to lie to you guys. This is so hard to see. I don't know why it's very blurry. The code is almost identical to Lab 1 again. However, we added in the length, the distance, all of the stuff that we need to change this lab around. I apologize, it is so grainy. But you can see the little highlighted bits that I changed, so sorry about that. Okay, here we can see this model a lot better. It's still a little grainy, but it kind of gets the point across a lot better. Here's the GLOScript model that our code has created. And our end result charge is 2.63 times 10 to the negative 8th coulombs. We can see here that the tape is kind of divided along all of the red bubbles and all the blue bubbles, and those are our individual point charges along the pieces of tape that we have segmented off. Okay, so for my conclusion, obviously this isn't a perfect scenario. The GLOScript model is a perfect scenario, but we don't live in that world, so causes for discrepancy could be human error. I could have my code a little bit wrong. I could have taken the initial data a little bit wrong. There could have been some inaccuracies in the tape not having the exact same charge, which again we assumed was not the case. And then we also could have lost some charge when we were handling the tape. These are almost identical to the first lab because we are running the same experiment, but in the GLOScript we changed things up a bit, and that is what is different between Lab 1 and Lab 2. Our first conceptual question is, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you would get when you use your experimental data to produce a point charge model to the value you got with your line charge model. The answer to this question is, the data would be much less precise. This is because superposition of the charges, which is what we did in this lab, which is essentially breaking apart the tape and individually adding those charges, is much more accurate. We see this concept in other sciences too, such as calculus. We can clearly see how much more accurate this model is than that of Lab 1. Lab 1 we got about -9 something times 10 to the 8th, and this one was just 2. So we can definitely see how much more precise this experiment was than the previous one. Our final conceptual question is, why do these estimates differ? Which value is more likely to be closer to the real value and why? Alright, so the answer to this one, I really want to hit home the concept of calculus because that's kind of what I know and relates to this. The answer is that, as previously stated, this model is much more accurate because the concept of superposition breaks down the tape into smaller segments of charge. When solving, finding the average of the whole and calculating is a lot less accurate than solving with smaller pieces and adding the results. We can clearly see I added a couple of Riemann sums. If y'all have taken Calc 2, I hope you have. The first image, we only have 4 blocks of what we would say is charge from the tape, and see how there's a lot of gaps that are missing in this graph. And as we break our graph into more and more dots, we can see it covers a lot more of our graph. So it gets it closer and closer to the area of these curves. The same concept can be used for the charged tape, because as we break the tape down into smaller and smaller segments and calculate those charges, we get closer and closer to the actual charge that the tape has, rather than just an estimate of the entire piece together. Thank you so much for watching. I hope you have a good day. Please give me a 10 out of 10. Thank you.